Assembly Language Tutorials, Chapter 6, Part 2. In the last video, we covered on these flags. There are 5 types of flags. Even there are so many of the flags, but these are like the ones which are generally used. And we talked about all these operations and how they set these flags. So in today's video I have added a few more assembly instructions, and I mentioned that this test and compare instructions, they are also like ANDing. So but what happens in a typical AND is the destination gets modified, but here the destination is not modified. Neither of them, neither test nor compare modifies the destination, but it sets the flags. Now the test instruction, it sets the sign flag, zero flag and parity flag, and the compare instruction, it sets the sign flag, the zero flag, the parity flag, the auxiliary carry. So it's not doing anything on the overflow flag. None of them are actually doing anything on the overflow flag. That means we can never have such a situation that test or compare is doing some kind of overflow. So the overflow is possible with either AND here, or maybe if we are doing some addition, so while adding two numbers or something like that, so that time the overflow will come. So let's quickly run through this. I'll set up a breakpoint. Let's debug it and see how the flags are being changed. So as you can see over here that we are at this breakpoint, so this guy hasn't been executed, and in the EX register, in the least significant byte, so we have 09. So what happens is, I'm going to test. Basically test is an AND operation, so the binary equivalent for hex 9 would be ANDing with this. And by the way, I zeroed out the EX flag, so move AL 1001. So the hex in the hex 9 is actually 1001. So if I AND it with the same, so let's see what's going to happen. So we have set the parity flag. So the parity flag, the PE is the parity one. It just counts the number of set bits. So what are the set bits? We have one bit over here and one bit over here, the same width, so nothing changed really. So the number of set bits remain the same, which is even. That's why the parity flag is set. Now let's move forward. Now let's compare it with this guy over here. Now compare is again going to do an AND operation. So we have the little table over here, the destination and the source. So this guy is the destination, so it's going to do an AND with this guy. So it means is, now as we can see that this guy is a little bit bigger than the other one, right? So the 9 over here in binary, it is 1001. We just talked about that. So this guy is definitely bigger than that. What's going to happen is it will hit this criteria. So the zero flag would be 0. If it is not 0, it will be set to 0. So this wouldn't changed. And the carry flag, it would be set to 1. So if that happens, it means that the source is bigger than the destination. So let's see that. So now the carry flag is 0. So if I step through it, so it becomes 1. So clearly the source is bigger than the destination. Obviously we can see that. So we have covered all these conditions, like addition, subtraction, we already did that. So now we have all these Boolean operations, AND, OR, XOR, and now we have also covered the test and compare instruction. So what do we do with this? Actually, based on these operations, when the flags change, we want to do something. So that something is actually called jump. So what happens in assembly, there is no such concept of like if statement or calling a function just like that. So in the previous video we talked about having own procedures and how we can call them. So there is no such thing as if statement. So what we have is a jump statement. So this is the conditional processing that we want to do. So the carry flags, all these parity flag and overflow flag, all this E flags register is super important. Without this we cannot move forward with any kind of conditional processing. So now that we have given enough stress, so let's see what are the different jumps instructions available. So I'll stop the debugger over here. In the previous video, so what we used to do is, like, we used to have some instruction 1 inst1, and then I would call proc something, proc test, and then I will have instruction 2. So that's how I used to call them. So what we want to do is we want to call this procedure based on something which has been done on the flags. So whether it is even, whether it is overflow, something like that. So what is going to happen is, let's say I am checking for the parity flag. So if p is 1, then call my proc. So something like that. So this thing, since we do not have the concept of if statement, we use jumps here. So I will comment out these. So these are the jump instructions, like all the jump instruction. Now the number could be signed or it could be unsigned. How we will know that whether it is signed or unsigned? But that depends on the data definition. Remember, in the first 2-3 videos we talked about bytes, d word, sd word, s byte. So those are the signed versus unsigned. If it is byte, it is definitely it is the unsigned part, and if there is s byte, so that is signed. So s stands for signed. So that's how we differentiate whether the unsigned something is happening. We do an operation like move, add, or something. So let's say over here, so now we are directly assigning value, so it's unsigned. So but had we have some kind of like num1 then s byte something, so, and if we wanted to do something on the num byte over here, so that would count as signed. So that's how we differentiate whether it is unsigned or signed. If this video doesn't make sense, probably you should go back and check my other videos, because this is like we are building the concepts and eventually we dive into programming. So based on the concepts we dive into that. So if this doesn't make sense, you have to go back and you have to check those videos. So because this gets so many moving pieces in assembly, it's just so many moving pieces, and it's very easy to lose track of. So anyway, now we know that we are going to call this function based on some values on the flag. So these are the different jump instruction. Now these are the conditional jumps. It could be unconditional jump also. So it is possible that over here, without checking anything, right, without checking anything, suppose I have a block over here, label 1, and over here I go to, like, I write label 1, so it would work. It's an unconditional jump, means I'm not checking anything, just whatever happens, go here, right? So even the jump could be far jump and near jump, but we'll not get into that. So our scenario over here, because we know that these are all unsigned, because we are not checking the signed bytes or anything, so we would be checking the stuff over here, right? So let's run this program again and see where the mapping lies. Okay, so I will step through it, and here we have parity flag set to 1. So that means, where is our parity flag? This guy, right? If you can see in the unsigned table, so if you see that jp/jpe, so parity is even, so it means even number of bytes are set. So means it's not much useful. Means I'm not sure like which would be the scenario whether your parity is 1 and you would want to jump to a certain location, but this is how technically it works. So let's look for something else. Where else is we have any parity? We do not have any, right? So let's step through it. Let's see if some more flags are being set. So as you can see that carry is set, cy, and polarity, the sign flag is also set, and also the auxiliary flag is set. So in our table here we do not see any auxiliary, so we'll simply ignore them. So but we can see that the sign flag or the polarity, I guess, so this is actually the sign flag, but Visual Studio shows you PL. So if any confusion, you go to here and you will know that. That's why I have this mapping. So carry is set, and this is 0, so P becomes 0. Let's rerun it. So now P is 1, only P is 1. Okay, now carry is 1, P is 0. So let's see our table. So if parity flag is 0, it is odd parity, is not much useful, but we have this guy over here, the sign flag. Even that is also not here because this is not is unsigned thing, so it's not useful. So the only thing that is useful to us is the carry flag, which is set. So carry flag is 1 over here, CF equals 1, the third item. So it says that below / not equal or equal. It means below or not above. So this is the way the Intel the documentation, this is actually table I got from the Intel manual. So we now know that the destination is actually less than that. So that's exactly what we have here. If carry flag is set 1, 0 flag is set to 0. That's exactly what we have here. 0 flag is set to 0 and carry flag is 1. It means that the destination is smaller than the source, and that's what we have in the manual as well. So even though this also could be possible that CF or ZF equals to 1 or CF equals to 1, both says it's below, means the destination is smaller than that. So likewise there are so many other stuff also. So based on the comparison, like this typical example is actually comparing like in the normal if statement, we compare two things. If it is smaller than this, do this, otherwise do that, stuff like that. So that's a good use case over here. So I suggest from now on you take this demo, and it's already there in GitHub, and I will be uploading this table as well. You keep experimenting these things because these are like endless possibilities. Like you figure it out, you spend time and see the how flags are changing on which operation. Now we know that we have the operation like the addition, subtraction, division, multiplication, like the typical arithmetic operation. Then we have shift operation, shift left or shift right. So I haven't covered all the scenarios, and it's not possible to cover them because the videos would run for eternity. So but you test them out, and then the logical operations, so the or, not, stuff like that, the test and the compare instruction. So that what we just saw over here. So test these out. While you watch these videos, you run these demo, test them out, and you see whether on which scenario it would be useful. Now I have covered just for one, like checking the greater than smaller than number. So now I know that this number is actually, had it been something else like num1 over here, something else, and if I see that the carry flag is set to 1, so what I could do is over here, so carry is set to 1, so JB, I would write JB and then label 1. So and then label 1 my code, I don't know what to spell it, something else. So whatever, you know, like this label would be there, and suppose here you have move EAX 9 or something, or maybe you want to call a function call my proc. So, and here it would be something else, like my proc and p, and here you are calling, so let's say some Win32 API. I have some videos on Win32 API, so I will cover in assembly also how to call them. So you get the point, right? Means you check the comparison, you see that this flag is set, and now you want to call on this guy. So how you get this JB thing? You do not have to remember all the thing, by the way. You keep this table. This is from the official Intel manual, so it's the one you should refer to. In Google you will find so many, so you just ignore them. This is the official one. This is how the CPU works. So they have manuals and you could download them, it's for free. So based on that you will get these, like the jumps. So I hope this video is helpful, and in the next video we will talk about the conditional looping as well. In the previous videos we covered about jump and loop, and now here we have elaborated on different types of jumps based on the flags, and the flags are being set based on the operations. In the next video we'll talk about conditional looping. So I hope you enjoy this video. Subscribe to this channel so that you would receive so many awesome videos like this, and put a thumbs up and have a good day. Bye bye.